So just would like to share the agenda of what we are going to learn. This is not a training that would happen in 10 hours 15 hours, not like that. It's going to be at least 100 hours training or even more. Okay. Because DevOps is very big topic. You know if you are a .NET engineer, uh, when you asked what you have to learn, you say .NET. It could be ASP.NET or C Sharp or whatever. If you're Java, they say, or you say Java. As and when new packages are supposed to be used, you can go and then use them. But when you say you are a DevOps engineer, uh, what you have to learn, if someone asks you, then you cannot answer. You cannot answer what you have to learn because it's a vast subject. You should have understanding on everything that uh, where your applications are running. You should have understanding on all the environments. For example, your developers are into Java, you should know how to set up Java and then ensure that how to automate Java kind of applications. If it is .NET, you should know. Go, you should know. C++, you should know. If it is Azure or AWS or GCP, any cloud, it's a Docker, Kubernetes, or writing scripts and then writing scripts for Windows, scripts for Unix based systems. It's quite complicated stuff, pretty complicated stuff. But one good thing is, you don't need to be master of everything. You don't need to be master of everything, but you should be a jack of all trades. That means you should know each and everything, but not necessarily you have to be master of anything. Not necessarily. You should know everything actually. What your system is, how to what where your applications are running, how to connect them, and what operating system it is using, and then how to use certificates, how to automate things, how these kind of things you should know everything, but you don't need to not need not to be a master of anything. That is one important thing, right? So this is what actually I will share the curriculum. Let me share my screen. Let me share my screen. So first we will discuss about actually today we will be discussing about what DevOps is, what we gonna learn in DevOps. We will be discussing about what DevOps is and what we are going to learn in DevOps. Uh, the fundamental part of DevOps is you should know Unix, or you should know systems that use Unix. That means Linux systems that are that are Unix based, basically Unix based systems like Linux. And there are various flavors of Linux. Okay, open source Linux are there mostly. uh, Red Hat, Fedora, they call it as. There are various distributions of Linux. That means the operating system kernel, that means the core of the operating system is Linux, but different organizations or different open source communities or different companies develop different flavors of Linux. Like Debian is one distribution, Fedora kind of a Linux is one distribution, or SUSE Linux. Okay, like that there are different. Ubuntu is one Linux. Okay, there are various distributions of Linux. So we will be discussing about the basics, Unix basics, the commands, Unix commands first. What are the Unix commands? Actually, what is the Unix system? And also we will discuss about Unix based things. And the second thing we will be discussing about Docker. You may ask me why Docker. Wait a minute. Second thing we will be discussing about not the Docker but Git and GitHub, not GitHub Actions. We would be discussing about Git and GitHub. That is the second thing. And then we would be discussing about Docker. What containers are Docker is. Some of you might be, you may feel like pretty difficult to uh, understand these words if you are fresher or you are very new to the system. It's quite, don't worry about that, difficult to catch these words. Docker, Linux, GitHub Actions, GitOps. These things are pretty tricky, but nothing to worry about that. You will understand. So one thing is a Docker is something like a virtual machine or compact virtual machine. We will discuss about that. We will be discussing about Docker. The entire world, the entire cloud is running using containers. Yeah. So Docker containers are very famous. And then we come to Kubernetes, or some people pronounce it as Kubernetes, whatever. Kubernetes or Kubernetes. This is another kind of a component that we heavily use. All DevOps maximum companies heavily use this. Okay, and then we discuss about Terraform. Terraform is also infrastructure as a code, because ultimately your applications will run on infrastructure. So infrastructure is not, you cannot go and then enable the infrastructure, rather you write code so that the code would enable the infrastructure. Okay, because if it's not one computer or one system, right? If for an organization it would be thousands and thousands of computers might be there, systems, thousands of operating systems are running in an organization. You need to automate them. Automate them means it's not a manual intervention. It is not a manual intervention, rather we write code for the things to execute. Okay, Terraform is used. Similarly, Kubernetes also for automation and orchestration. We will discuss about that. And the other thing is Prometheus and Grafana. You hear a lot about Prometheus and Grafana. Okay, which we call it as monitoring. Generally, we call it as golden rules of monitoring. How your application is working. Are there any errors? Are there any traces? You found anything that is not working? Okay, these things actually we get to know. So what is the easiest way? An image is equivalent to 1000 words or 1000 sentences. With the graphs actually we can easily understand rather than reading the textual things. So Prometheus and Grafana, all these things are fetching all the information about your systems and then showing them on the graphs how the system is working, whether it's working well or it's not working, and everything that we use for monitoring. We call it as we use Prometheus, Grafana for monitoring. I will explain Prometheus and Grafana. Okay, and also we discuss about SRE foundations. What is site reliability engineering? Because DevOps and SRE are, they are not same, but yeah, most of the responsibilities or most of the systems, particularly both of them, both of the uh, uh, engineers or engineering teams they use are same. SRE is completely into site reliability engineering, ensure that how the system is working, and then if the system is down, what I have to do to make sure that the system is up and running. DevOps is more about development operations, right? These are the things we are not going to discuss on Azure and AWS. Azure and AWS especially we will not discuss. If required, we will see that any one of them we will pick and we see, because it requires cloud accounts. So I will see if at all I get any cloud account. We will see. We will just keep it on hold as of now. However, yeah, we may. I will explain that. Nothing to worry about that. But I am not going to give any promise on these two things. Let's focus on these things first, and then automatically you understand things. It's a cumulative learning curve. Okay, we also discuss about writing shell scripting. Writing shell scripting is part of everyday job of a DevOps engineer. One should write shell script, one should understand how the script is working and make sure that things are working. For the automation, you need to write some script. Okay, on top of this, on top of all these things, if any one of you feel like, yeah, we also need a programming language for scripting purpose, let's say Python is very widely used. We will also discuss about Python, but we'll keep it aside right now. The Azure part and then the Python part we will keep it aside. Okay, this is a steep learning curve. Steep learning curve means pretty upward direction. It's the learning is, it start as small, but it will grow like anything. It will you have to climb lot of steps in order to understand DevOps. Number one, DevOps is not easy. Number two, DevOps is not difficult. That's a tricky thing. Yeah, if you are doing DevOps is not easy, DevOps is not difficult. But what is DevOps? You need to know a lot of things to be a DevOps engineer. Okay, you need to know a lot of things. If you are into HTML or CSS stuff like that, you should know only HTML and CSS. Okay, but if you are in DevOps, you need to know a lot of things, lot of things, to ensure that your systems are up and run, your systems are working seamlessly without any issue. Okay, I also encourage any of your friends or somebody would like to join the session. They can also join the session. Please share their link and then ask me to. You can ask them to contact me. Wait a minute. Right. Cool. So first thing first. What is DevOps? This is my question. What is DevOps? What do you know about DevOps?
It's an automation tool to deploy these things
Yeah,
into our server run.
it's an automation to deploy applications. Deploy applications means, for example, now we are using Google Meet. That means how can you use Google Meet in your browser? Because Google Meet has been deployed somewhere in Google servers, so that we are able to access Google Meet, and then we're able to use Google Meet. Okay, right. So DevOps means generally development and operations. Development and operations are uh, two different things, and responsibilities and then accountabilities are shared between two different teams. If you have been working in software industry for more than, I think, 10 years, or even more than 7 8 years, you clearly know that what our operations team does, what is the release management team does, and then what development team does. Okay, so it's pretty tricky if something goes wrong. Actually, you know sometimes development team, if something goes wrong on their server, something goes wrong means something is not working as expected. So there would be a blame game always in any organization. It's not about politics in an organization. Blame game is part of the organization, how organizations run. uh, okay, for a newcomer, you may be surprised that there is a blame game, but if you are experienced, then it's pretty much part of every organization. So if there is an error, as long as everything is working fine, absolutely everything is working fine, there is no issue. Okay, so if you find anything I'm speaking, if you find it difficult, please ask me. Then I'm okay to explain in Telugu as well, because all the candidates here are Telugu speaking folks, so there is no problem at all. I'm telling you, don't shy, don't feel shy or anything. Be open. Okay, it's kind of, let it be a discussion kind of a thing, and then put a lot of efforts to learn things. Right. So uh, so developers, that means who develop the software, who develop the software are called developers. And then who is going to manage that software post development or during the release of the software? Maybe release team or build a team or operations team. There are different teams. But when the problem comes, as long as everything is working fine, there is no problem. Absolutely everyone say, yeah, our software is working fine, etc. Okay, done, everything is perfect. But the problem starts, the issue starts when there is a problem. If all of a sudden the server is not working uh, uh, due to overconsumption of maybe processor or RAM. How many times you hard restart your computer because it hangs? A simple thing. You ought to hard restart your computer. Soft restart means, what you do, you go to restart option, Hard restart means you go and then directly push your switch on button, then it would restart, your computer would be restarted, which is you are forcing your your computer to restart. Okay, you are not forcing, you are not asking your operating system to restart, rather you are asking your hardware to restart, because your system hangs, because your system is not responding, it's in the waiting stage, it's not responding, the process is not responding. Then who has to take the responsibility? There the problem is, developers say that there is some problem in the infrastructure says that there is a problem in the development itself, there might be some problem in the development as well. Maybe developers did not write efficient code so that it is eating up all the RAM. There could be chance, right? So DevOps is here, development and operations. DevOps means, dev means development and then ops means operations, is kind of set of practices the organization started uh, following some practices, principles, and the cultural philosophies. Okay, the ultimate aim that to embrace this kind of a cultural philosophies is to improve the collaboration and communication between software development teams and then operation teams. That means operation teams and then software development teams, they should communicate and collaborate to solve the issue. Organizations, how many times you or me or somebody become very adamant to your manager that it is not our problem. Okay, there is very smart guy in your team or in my team, okay, let's go and then fix the problem, even though the problem does not belong to him or her. It happens, you know uh, because developers think that no, it's not our problem. Okay, the other team thinks that it is not our problem. Then what happened? There is keep on blame game is going on. The manager is the person who is completely crushed in between, right? So it happens very naturally in any organization that there is a problem with the development team and then operations team. So DevOps is here, so for the better communication and then collaboration between development team and then operation teams. So what it is going to give, what is the output that we are going to obtain from this kind of philosophy? Okay, then what happened when development team and operations team work together? Okay, what happened? Okay, because they follow the same better culture. Okay, they so the delivery life cycles, okay, eradicating issues or bugs, okay, to automate the entire process, everything would become a seamless approach. What is the aim? The aim is, whether you are a developer or you are a some other engineer, the ultimate aim is make sure that the software should run seamlessly. Ultimately, the customer should use your software without any interruption. That is ultimate aim. So how do you achieve that ultimate aim? By embracing, the organization should go and embrace, say, let's go and get the DevOps culture. Okay, the culture is collaboration, shared responsibilities. Shared responsibilities means, yeah, for example, writing some Docker file, development team writes a Docker file, but operations team can understand that, the DevOps team can understand that, hey, some of the operations team, you write a Docker file, but it looks like it's not uh, as performant as it is supposed to be. They go and then change the Docker file, and then they communicate back to the developer, say, I have gone and then changed your Docker file, so now it works very well, it performs very well, it uses less memory. And then that is the culture, that is the communication and collaboration that happens between the team. Okay, and also shared responsibility. Okay, if something is not working, it is not the blame game that everyone push on to the other, everyone keep the issue on somebody else bucket. each other's bucket. Rather, the responsibility is shared between both the teams. Okay, and then continuous integration and continuous delivery. The way how software is delivered many years ago and then recently has changed. So, Srinu, if you still remember that how frequently you used to release your software 10 years ago.
I think every 10 days or 15 days, sir.
Every
No,
10.
no, sir. Yeah.
Yes,
No, 6 months also. Yeah,
6 months
when we working with the
generally.
waterfall at the time, we are, yeah, generally 6 months or 4 months like that.
Yes,
But nowadays, not like that.
simple thing. Yes, yeah, the software release is every quarterly, half yearly, or something like that. It used to be. That means maybe hot fixes or something is really not working, they may fix and then release within 15 days or 10 days. But generally, the new release of a software happens every 3 months or 6 months life cycle. That too, lot of process used to be there. You need to raise a ticket, you need to take it to the build team, release team, and then they have to approve. You need to ensure that what all changes you are making, you have to send it to the source code repositories. They check everything, they ensure that everything is working fine. They checked it, they moved it to the staging environment. That staging environment is nothing but, it is analogous or similar to production environment. They say that, yeah, everything is working on staging, that means it should work on production, and that's all. Even then there might be some issues in the production, but they may not be seen on the staging environment, right? So if there is a problem, once you release a software today, if there is a problem in the software, so because problems in the software is, you cannot, it's an inevitable thing. You cannot write a software without any problems. No one can write a software without any problems, because problems may not be from the development side, problems may be from different sides. Then there was a very big life cycle or approval cycle, that sometimes to move your changes you may have to go to your vice president level. You may have to get the approval from your vice president in order to uh, uh, change your code, and then push the code to the central repositories, and then send the code to the production. It's a heavy, very heavy process. A lot of emotional thing, and then a lot of emotional. It requires some emotions as well, because usually the operations team and then build team are used to be very cruel actually. At least when I worked, they say that they used to target you directly. Why did you fix the bug earlier itself? See, it is very big work for us, kind of a discussion happens. But generally they don't think that it is for the organization, it's not for you and me, right? But when you look at today's software release is pretty fast. Customers are demanding the features to be released. Customers demand features every now and then. Customers would not wait for 3 months or 6 months for the features to be released. Every now and then intermittent features to be released to the customers as fast as you can. They want new features always. They cannot wait for 6 months for the new feature. Then DevOps comes with a solution called continuous integration and then continuous delivery, CI/CD. If you have you ever heard of it, CI/CD. We also discuss about Jenkins in between. I will add it. CI/CD. CI/CD means continuous integration and then continuous delivery or deployment. Okay, then a lot of things came into the picture. You have to take care about the security, you have to take care about infrastructure. Infrastructure is very huge infrastructures nowadays due to cloud computing, right? You should have a lot of collaborative tools, something like bug tracking, issue tracking, even chart based operations. Support teams also came. Chart bots came. Rather than somebody gives the solution, then even nowadays chat bots are giving the solution. Recently somebody has asked me, can we develop a software in Slack? If you know about Slack, Slack is a collaboration tool for teams. They were asking me, why can't we develop a software that reads all the messages in Slack for an organization, and then automatically it can give answers if someone asks a question in the Slack through a co-pilot. Co-piloting is very very famous nowadays. Every software that is going to be every innovative software that is going to come from now onwards, or the existing softwares, they would come with Copilot. My gut feeling is writing Copilot agents is going to be, another big thing in software development. They would bring Copilot into each and everything. Okay, you know already what Copilot is. You are writing an email, you are texting in your WhatsApp, you get some predictions or help to in the bottom. You may write wrong spelling, or you want to fill the sentence. You get all the help. It's nothing but a co-pilot. Somebody, that system is helping you to do something, which is called co-pilot. Nowadays GitHub or GitLab co-pilots came. That means you write code and then it writes code for you rather than you go and write the code. It may not write 100% correct code, but it writes some part of the code for you, rather than you go and then search in Google, copy paste in your machine. The Copilot writes code for you, then you can go and then change. You can't believe me, the software that takes at least a month or 2 months to develop, I developed it in 3-4 days by using ChatGPT. I know what to be done. I keep on searching for give me the code in Go, give me the code in Rust. It keeps on giving. This, it may not give 100% correct code, but I know code. So I can just pick the code and then change certain things in the code and then execute. Right. Yesterday itself, I think Srinivas told me. So the days that we worked, we learned from the scratch and then we were doing everything from the beginning. But we used to write a lot of code, but nowadays the current programmers may not be able to write. That's true. The reason is we know how ASP works, how we know how ASP.NET works, how it parses, how it renders, how ultimately the HTML output or output stream is given back to the system. But nowadays no one cares. We know how Ajax work. We know how exactly the React or AngularJS or UJS, whatever you are talking nowadays, we know how exactly it works, because we started with Ajax, not the jQuery of Ajax. We know exactly how Ajax, asynchronous calls, how to make asynchronous JavaScript with what is it, Ajax XML with JavaScript or something. We know how it works, right? But the current programmers need not to know how Ajax work. They just need to go and use ChatGPT, or they just go and use the components that are given by React or Angular or whatever it is. There is a clear difference. Okay. So as a DevOps engineer, this is what the DevOps is. I hope you understand what DevOps is. DevOps is development and then operations. DevOps teams, it's a collaboration and it's a culture. What the culture, it fosters better delivery of the software. Ultimately, what the benefit that it's going to give, it gives the software is delivered ultimately to the end user or the customer. A better software is delivered to the end customer. Ultimate goal is that, but with a faster pace. Faster pace is very important. Customers need not to wait for long time for their software or for the features they ask to be delivered. Okay, so we have to discuss about many things over here. Infrastructure as a code. First thing, for automation, here we use Unix and continuous integration and then continuous delivery. Okay, we use GitHub Actions and GitOps. Continuous integration means whatever the code that you write in your system, as soon as you push it to the GitHub, it is automatically integrated and ready to execute. If required, it would be deployed automatically. I worked in an organization called OVH, which is a cloud organization. There is zero testing team in that organization. All the testing is done only by developers. You have to write unit tests for each and every piece of your code. You have to write system tests, you have to write integration tests, you have to write scale tests, and all the tests. Everything is automation. So whatever the code you write and then you push it, once it is merged, it is in the production. Actually, per every day, I think at least 100 to 150 releases happens in the production. In the production, okay. I'm not telling in the, so whatever you the code you write, as soon as it is tested and all, it is asked for merge. Once it is merged, and it would be in the production. That is the process they follow. Initially, I used to doubt their process. How can it happen? Because I am very much worked in an environment where testing team is actually very important. But when I observed that how the system was working, I understand. Yes, this is how they are doing things, right? And then infrastructure as a code, we discuss about Terraform. Infrastructure as a code, we discuss about Terraform. Deploying your applications, we discuss about Docker and then Kubernetes. How do you deploy your applications? First, we discuss a lot about Docker, and then we will also discuss about Kubernetes. Collaborative tools, where the tasks are there, where the uh, tickets are there, what all tasks that you have to work, what are the errors, what are the issues for each and every task. We use collaborative tools in GitHub itself. For security is one of the very important prominent features, parameter in DevOps. So for security, we will discuss about certain security aspects, what security is, how to develop applications in a secured environment, how to ensure that your environment is highly secure, what are the tools that we can use to scan that there are no vulnerabilities. Vulnerabilities means loopholes or something, so that the attacker will not able to access your systems. It's one of the important things is called security. We discuss about all these things in the upcoming sessions. Now, first thing what I want you to do is, if you are using Windows systems, okay, first thing what you have to do is, if you are using Windows systems, then install Windows subsystem, sorry, Linux subsystem for Windows. This is very important. And then you have to install Ubuntu Linux subsystem for Windows. What you have to do, you have to go to your uh, control panel, then you need to enable the tools. How to enable Windows subsystem for Linux. Sorry, it's not Linux subsystem for Windows. I'm very sorry. It is Windows subsystem for Linux. Windows subsystem for Linux. Okay. Windows subsystem, Linux Windows subsystem. So these are the steps. What you have to do here is, you can go and then perform these operations in your system. Otherwise, first of all, what you need to do in order to do that is, Windows subsystem for Linux. First of all, you have to go to your Windows 10. If you are using Windows 10, go to programs and features, and then turn Windows features on or off. Go to control panel, and then you could see turn Windows features on or off, and then here you have to go and check this Windows subsystem for Linux. The reason is, DevOps means it's full of Linux. Okay, without Linux or Unix based systems, you cannot be a DevOps engineer. To become a DevOps engineer, not only DevOps engineer, nowadays it's like that. If you want to become an software engineer, the most important thing is you should know Linux. That's all. Without Linux, I don't consider anybody as a software engineer because of the current trends. I'm not saying that Windows is bad, .NET is great, Java is bad, not like that. The system, the current trend is Linux is everywhere. Linux is, you are using ChatGPT, the servers are running in Linux. You are using Google Talk, Google Meet, the servers are running in Linux. You are using Azure, 99% of the Azure servers use Linux, not the Windows. Even Azure is a Microsoft product. So Linux is everywhere, and particularly DevOps. Why do you use DevOps? To execute your application seamlessly in the cloud. Okay, if you want to execute your system seamlessly in the cloud, uh, you have to write the systems that should run on Linux, because in the cloud 99.9% systems are, they use Linux. So number one, either you can use direct Linux operating system like the way how I am using right now, or you can go and use Windows subsystem for Linux. Windows subsystem for Linux. How do you enable Windows subsystem for Linux? I'm going to put it in the chat just to follow this. That's the chat box. Okay, this is where Windows subsystem for Linux. You should know, you should use Windows subsystem for Linux. So go to Windows programs and features, go to related settings, okay, and then under the programs and features page, turn Windows features on or off. There is something called turn Windows features on or off. Then click on Windows subsystem for Linux, and then click OK to save your changes. Hit restart now and finish the process. After that, you need to install Windows subsystem for Linux. Okay, you enable the feature. This is to enable the feature. This is to install. Follow the steps. Then you install Ubuntu. If you can't do it, tomorrow I'll show you. Okay, I'll connect the call from my Windows system, and then I'll show you. Okay, try to do this. So, or if you have a Linux machine, that's well and good. You don't need to do anything with this, which is called Windows subsystem for Linux. You need to do that, right? Then we will discuss about what Linux is or Unix is. Unix and then Linux systems are very important. You need to know what Linux or what Unix system is. Okay, sorry, it is Windows subsystem for Linux, right? So coming back to the Unix based operating system. Has anyone worked on Unix in your academics or professionally? Have you ever used Unix?
No, sir.
No. Academics you might have gone through, Srinivas.
Until we know some commands, but
Right. Right. It's very very important. It's very very important to know Linux or Unix system. Without that, you can't do anything in the current cloud computing or DevOps. So please go and embrace Linux or Unix systems. Right. So why do we use Unix? What is Unix? Unix is a operating system basically, which was developed using C language, with the help, I think, with the mixture of assembly language and C language, but most of the Unix systems were developed using C language. And then at some point of time, Linux operating system became very famous. You know who is the father of Linux operating system? Linus Torvalds is the person. I forgot his name. Linus Torvalds. Interestingly, he is the person who invented Git as well. Whatever the Git that we are using nowadays, it is also by that guy, Linus Torvalds. Uh, he's a Finnish guy. In 1991, actually, he started developing a Linux operating system, and then he open sourced it, making it as the open source is nowadays everywhere open source. Whatever we talk about open source, but some of them are really true open sources, some of them are not true open sources. There are some hidden agendas. Let's say MongoDB is not a true open source, right? But most of the Apache softwares, MTU licenses, these are all real open source softwares. Okay. MongoDB is not a true open source software, but however, it doesn't matter, right? So Linux is a Unix is an operating system. Linux is based on Unix operating system. Even the MacBook that we are using nowadays, it's based on a Unix based operating system. Only Windows operating system is different than the Linux or Unix versions. Windows has a separate kernel. Windows has a different way of doing things, separate way of doing things. Okay, but most of the operating systems, for example, Android you are running nowadays everywhere. Android is there. Android is based on Linux. Linux is based on Unix. It's not. We cannot say based on because it follows the foundations of Unix. It follows the same path that Unix has created. Okay, there is an operating system called Plan 9. Now whatever the Go language nowadays that Google has developed, there are some guys like Kim Thompson, Rob Pike, and all. These are actually the guys who implemented an operating system called Plan 9, which is a network-based operating system, which was uh, technically very savvy, wonderful operating system. But commercially, I don't know whether they have not promoted or don't know the reason, but it's not commercially seen operating system. But technically, it's pretty good operating system. So Unix is a we talk about Unix. When I say talk about Unix, mostly 99% these things are common, same for Linux as well. Unix is a multi-user and then multitasking operating system. Unix operating system. First thing, multi-user and multitasking operating system. Multi-user operating system means there are multiple users at once can connect to the Unix system at once. Initially, Windows was not a multi-user operating system. Later on, Windows has become a multi-user operating system. DOS prompt was a single user, and DOS prompt was not a. DOS was the core of Windows earlier. Uh, so DOS was not a multi-user. I think DOS was also not. I think DOS was a single tasking, not multitask operating system. But Unix was, even from the inception or whatever. Okay. Unix is pretty stable and then reliable operating system. Multi-user and multitasking operating system. Multitask means what? Okay, it can do multiple tasks concurrently. Okay, if there are more cores, of course, when it was developed, there were not more cores, only one core operate processors were there. But multitasking was not a parallel computing that time. It's like when if you really gone through your operating systems, you understand. Operating systems has got some characteristics. Operating systems, when you go through the processor or processing, is one of the key component of any operating system. There is a kernel, and then how each work is done, each task is done by your operating system is actually by multitasking. You were listening to Winamp player in olden days, for example. You are using a Paint, MS Paint, and then you open a notepad. So these three apps are running. If these three apps are running, then definitely, if these three apps are running, means it's a multitask. Whether they are running in parallel or they are running not running in parallel, but it's a multitasking. You can listen to songs, you can draw something using Paint, and in between you can open Notepad and then type. At least listening and painting, two things you used to do at once. So it's a multitasking. Okay. So Unix-based operating systems are pretty stable and reliable. Okay. They have robust memory management, efficient process scheduling. Robust memory management means they use as many resources as they are supposed to use. Okay. And then efficient process scheduling, because ultimately every application you run is a process. We will discuss about this. These are all the important things. Even we will discuss about it in the next class, don't worry. Efficient process scheduling, that means there are multiple processes are running in your system. Of course, multiple processes run your system. Every application that you open or every command that you write, okay, it's a process. Whether it is Windows or then if you open a notepad, then it is one process. If you open another notepad, then it is another process. If you open MS Office, it's a process. Okay. Any application that you open, ultimately it's a process. Process, what that process contains some memory and some memory and some threads, one or more threads. If it is a single threaded or multi-threaded, we'll discuss about that later on. But Unix is very stable and reliable from the memory perspective, as well as the uh, process efficiently scheduling these processors. Unix has a uh, pretty good security. It's a very high secured operating system. Unix is a secured operating system. The reason is it contains the very strong security features. Okay. So for example, security features means, for example, a file is there. Okay, each file has what all permissions. Each file has got read permission or write permission. If it is an executable file, what we call in Windows, it is an exe file, it should have execute permissions. All these permissions weren't there in Windows. Yes, they were there in Windows as well, but they are not as robust as Unix. Unix has had all these features and very early versions of Unix, but DOS did not have. Later on, they added these features. Root user, okay, sudo user. There is a name that you come across, sudo user or root user. These are the these are very regular things that you hear in that Unix based operating systems. Network capabilities. Okay, Unix operating systems are designed networking in mind. Okay, by default, by design, they are network based operating systems. Okay. Command line interface. When you are watching a movie, then we watch a lot of movies, but we laugh. Being a software engineers, we laugh because what they do. If anyone watched the movie called Alavari Matal Kardale Verle, that right, that movie, then Venkatesh is sitting. They say that he's working on a computer, and they say that something got wrong. Something goes wrong in your system, in his computer, and that he keeps on typing on the system. You can see a lot of things are moving on his system. Okay, I put a video as well similarly some time ago. So generally they are all commands. If you run any Unix based operating system, they are completely CLI features. CLI feature means command line interface, where you do many things in Linux through commands. It's good or bad. It may be difficult for a novice user, a beginner, but it is very much important for automation, because these commands can be executed through the scripts, which are in Windows also you can execute, but it little difficult in Windows. They are not as fluid as in Linux. CLI tools are there in Linux from the inception of Linux. Shell scripting, CLI tools, these things. Okay. uh, Modularity and scalability we can also see. Then it's command line interface, we can see modularity, you can see security, we can see uh, st- stability, stability and reliability, we see. Okay, uh, these features. Then you can open source. Most of the Linux versions are open source versions. The Linux kernel itself is a open source. Kernel means the core of the Linux, the engine that is used to run the operating system. It's an open source based operating system. On top of that, Red Hat has created Ubuntu has created a server operating system as well as client general operating system, a server version or a normal version. CentOS, there was a company who does that, but it got merged into Red Hat. Then Red Hat got merged into IBM. So there are so many versions. SUSE Linux, VMware has got their own Linux, Amazon has got their own Linux. Uh, Android is a flavor of Linux, in fact. So it's an open source operating system. Basically, the core of the operating system is open source. Okay, open source means it's generally pure open source, freely redistributable. You can redistribute the operating system. You can use it even for the commercial purpose. Some are not real open sources. Okay, they can use it. You can use it, but not you cannot go and then commercialize that. But Unix and Linux based operating systems are, you can also commercialize it. That is how Android has came into the picture. That is the reason, also one of the reasons why Android cannot be made as there are some clauses. Okay, you cannot go and then the core operating system of Android uh, um, as a payable operating system. You cannot charge. Basically, you can charge for some of the patents that are very specific to Google, or some are very specific to Microsoft, but you cannot go and then sell the whole operating system, something like that. You can redistribute it. That means you can add some layers on top of that and then you can sell it. There are some clauses, however. Because of all these features, particularly the security, modularity, and then command line interface kind of a things, multi-user and multitask operating system, I'd say. Because of all these features, Linux or Unix based operating systems are very prominent for DevOps. So in the next class, so let's close the class for today. Let it be an hour. Tomorrow we will try to make it as more than an hour. What we do is we will discuss about how the Unix operating system architecture is, what are the important file. It's everything in Unix is a file. One thing you need to know: everything in Unix is a file. If it is a socket, it is a file. If it is a process, it is a file. Okay, it's a file. It's a normal file. Yeah, it is a file. Everything in Unix is a file. It is stored in the file. Unlike Windows, everything is not a file. There are different categories. Okay, but Unix, everything is a file. Whatever that your kernel talks to your hardware, everything is a file in Unix. So we understand what is the architecture of that particular file system in Unix. You need to know the basic architecture of the Unix based systems. If you don't know the architecture, you cannot be a DevOps engineer. Basically, you cannot use Unix. You need to know the architecture. Okay, where configuration store, where executables are binaries, we call them as binaries. In Windows we call them as executables, but in Linux we call them as binaries. Where these binaries store, where these binaries, how the binaries are configured, how to set up the environment variables. Okay, how to give permissions, What are the things that we have to be keep in our mind whenever we are giving permissions? Everything we will discuss about Unix. We will discuss about the basic Unix commands. You need to practice them as well. I'll give you some exercises about those basic Unix commands. So the first task for you is, please enable Windows subsystem for Linux. Okay, you need to enable Windows subsystem